So let's try to have a first implementation of a queue. Okay, and as we saw in the case of the stack, we were using array as an underlying implementation, our data storage layer. For the queue also, we'll first try to use an array to implement a queue. Okay, so for example, say first of all, if I say that 5 has been added, so it means I have to go and add 5 to it. So where should I go and place in this array? In which position the index 5? Should I go and put it in the 0th index? Should I go and put it fourth? Should I put it in middle of it? How should I go about it? Should we put it at the 0th position?
Yeah.
Yeah.
Okay, perfect. Let's try to put it at the 0th position. So I'll put 5 here. Okay. Now again, I'm trying to do q.enqueue7. Where should I put this 7 now? Index 1. Very nice. Then again, I have to put 9. So with your logic, I should go and put 9 here. Okay. Now I have to do a dequeue. Now if I have to do a dequeue, which element should it return? What should be the value that should get returned from this one? What should it return? If it is a first in first out data structure, what it should return? It should return 9, but 9 was the last one which was getting added,
Five
right?
should return. 5.
The 5 should get it, right? Jahir, why are you saying 9? Again, I'm repeating, don't get confused. Okay, queue is a data structure in which whichever element which was added first will be will be removed first only, right? So 5 was the element which got added first, then 7 was added, and then 9 was added. So when I say that I have to dequeue, the first element which was added will be removed from it, right? So when I say queue.dequeue, it should return me 5, right? So if it is the case here, then what will happen is that 7 and 9 and 0 space 0 position element will become empty, right? Everybody good? Agree on this?
Okay. So
Perfect. Again, when I do dq.dq, now you tell me what will come out as a part of q.dq thing.
7 should come out.
7 should come out. So again, the 7 also has come out, and now I'm only left with 9. Okay. Now when I do q.nq, where should the 3 go? Tell me, where should we place 3 now?
We should go on 0th in the.
The 3 should go on the 0th index. Okay, if I go with Vivek, 3 should go at the 0th index, and I put it here and put 9 here. And if I suppose again, if I have to do q.dq, what should you do? Normally, I go and start picking from the left itself. So in this case, you will what will you take out? Will you take out 3 or will you take out 9? And try to think programmatically, because now as a human being we have a supercomputer mind, right? So I know that I have to take out 9, but if you're writing a program, you have to follow a particular pattern, right? You cannot keep on flipping between that. So far here, when you have to do, you had you first of all took out the element from here. In the second DQ, you took out the element from the here, so that is why you got 5 and 9. So basically you have been
Okay. Do we
dequeuing it from the left. Yeah.
Hello? When we are dequeuing an element, should we actually change the position of other elements also?
Now, if we start changing the position of the other elements as a part of DQ, that time complexity will be compromised, right? The time
Okay.
complexity, as you remember, I said the beauty of the queue is that the time complexity should be constant, whether it's an NQ operation or whether it's a DQ operation. But during the NQ and the DQ, if you start shuffling the positions, that will take linear time, right? The time complexity will start suffering.
So in this case, 3 should be added to third position, I guess, because
Yes. So ideally, yes, you are right. So the 3 should be, should not be positioned here. Whenever I say the 3 should get positioned to the next position of 9, because this is what we are trying to do the programmatically, right? So the programmatically we are saying that whenever I have to add any element, right? Whenever I have to add any element, I'll add to the right of it, and whenever I have to delete any element, I'll do left to it. So for example, in this case, uh, at any position of time, this is the pointer uh, towards which we have to enqueue it, right? We have to enqueue it, and this is the pointers where we have to dequeue it. So in the stack, if you remember, from the same side where we were adding element, from that side only we were also removing the element, because that time we wanted to have the first in last out or last in first out order. But in this case, since I have to have the first in first out order, so in one direction if I'm adding the element from another direction, I'll be picking out the element. So always the element will be added to the right of it, and always, the elements will be dequeued or removed from the left of it, right? So again, if I do one more thing, q dot nq and say 9. So again, what we'll do is that if I just create this one, so it will be 9, it will be 3, and again 9 got added. And again after that, if I want to do 10 to this, uh, what I see, I don't have any space left, so I won't be able to add any element to it. So even though the array has 3 elements left, right, still I will not be able to add any element to this particular array. So if we just try to implement queue with this array way of implementing it, what is the problem that we are facing? What is the issue with this approach? Can you guys tell me what is the issue with this?
Wastage of space.
Wastage of space. Very nice. So if we try to implement queue using a one dimensional array, we can definitely attain both the nq and the dq in a constant time. That is not a problem. But the biggest problem is the wastage of space. Even though the array still has few spaces left, still you will not be able to use it, because every time when you are trying to dequeuing it and every time you are trying to enqueue it, your positions keeps shifting, and once you have moved from one position to the right, you cannot use that space, right? So whatever this space that we have been left with, right, this whole space, this whole space, right, this is a wasted space, wasted, right? This is wasted. So this is one of the challenge when we are using array implementation. Another challenge is that array is always a constant size data structure, right? So that challenge already existed before also. So since array is a constant size data structure, if I want to have a dynamic size queue, again that is a challenge, because I cannot have more than 5 elements in a given array, because if I have a defined array of size 5, right? So that is another challenge. I asked you, I made you guys think about in this direction because I want a solution. So if this is a problem, can we do anything in this array to solve this problem? Can you guys think of any solution for this particular problem?
Should we dynamically increase and decrease array size?
Array size dynamically we can definitely increase and decrease. That will help us definitely in one of the problem, which is fixing the constant size of the array. But this wastage of space will still be there, right? So what we can do in this case is that one possible solution of that is circular array implementation. Uh, Basically, to tell you, there's nothing as such called circular array. Okay, there's nothing as such called a circular array which exists. But basically, what we try to do is that we try to represent a one-dimensional array into a circular array. What it means is that suppose I have a one-dimensional array like this. Okay, and suppose I started moving in this direction from the left to right. Suppose started moving in this direction from the left to right. And as soon as I enter the last element, after that there's no position left. So if suppose I'm here, then I move here, then I move in this block. So it was starting at 0, 1, 2, 3, 4, and 5. And as soon as I have to move after 5, I'll again come back to 0 itself. So some way, if you can enable this movement from the last to the first one, this array can start behaving like a circular array, and then we can treat it as if it is a circular array. So let's first try to see if suppose the circular array exists, can this problem of the wasting of the space can be fixed? And if it is fixed, then we will be using the single array itself, but we'll try to write a code to manage this overflow. Like whenever I am at the index 5, again after that it should not go to the index 6 because it will give the array out of bound exception. Rather, I should jump to the array index 0. Make sense?
Yes, sir.
Perfect. So let's try to see the same thing and see how it works. So suppose uh, this is my starting point, okay? And in the starting point, let's me tell me, uh, say right, you have two things. You have a front pointer and you have a rear pointer. Okay? Front pointer is where you keep on adding elements, adding elements. And suppose rear is the point from you remove the elements. Okay. So adding means NQ and removing means DQ. Right. So first of all, the one was added. Okay. So one was added. So one comes here. So one here is also my front also, and one is also my rear also. Now when I include two, uh, I put two here, and now my F is this index, but my R is still this one only. Okay, makes sense. And again, if I do q dot nq3, the q3 will come here, no, and now F will be this one, and this will get deleted, right? Similarly, when I do 4, now my finally F is here. So this is so far. This is the the situation is like this, in which my rear is still at that position and the front is this one, right? So now suppose till this point it was all fine, right? Till this point it was all fine. Now I'm trying to dequeue it. Now from where I should remove the element, guys? Which one should get dequeued? What should return? Q dot dequeue should be what?
1.
Very nice. So once I get the value as 1, uh, this space gets vacant, right? So what we'll do is that we'll delete this. Right? We will delete this, right? And my rear position will now no more be this. Now I'll be my rear position will become equal to this, right? And then suppose I'm again dequeuing it this here. So again when I'm dequeuing, now the rear is 2, so it will return 2. This will also get deleted, this element, and my rear will move from here to my rear will move to this position, right? And then again when I do a NQ, now this will be 5, and now this will be a new front, right? And this will get deleted. So what I see is that if I use this kind of data structure, I will keep on enqueuing. So now if I have to suppose enqueue q dot nq 6, then 6 will get added here. Then if I again do q dot nq 7, 7 will get added here. Q dot nq 8, then 8 will get added here. Then if I do q dot nq 9, then 9 will get added here. Q dot nq 10, then 10 will get added here. Right, this is 11. So what happens in this case, what we see is that since it is circular in nature, so we are not wasting any space. So the problem which was there in the earlier implementation of the array, because of the enqueue and the dequeue thing, we were wasting lots of space. In this implementation, we are not losing any space. Is it making sense, guys?
Yeah.